Tanmoy Biswas, I welcome you all in my channel Chemistry the Mystery of Molecules. So today we shall discuss about a interesting molecule, that is methane clathrate or methane gas hydrate. This molecule is considered one of the fuel for future. This is because this molecule can burn, means actually this is a ice inclusion compound of methane, so it can burn spontaneously. That's why it's considered as burning ice. So I know it's a very interesting molecule to you, so let's learn it in details. So what is a clathrate compound? According to definition, a clathrate is a chemical substance consisting of a lattice that traps or contains another chemical molecule. Okay, so in short, you may consider it's an host guest complex or inclusion complex, means something is inside of something. Okay, so in this case the cage is considered as the host according to UPEC, and the guest molecule which is inside the cage produced by the host. Okay, like you may consider a thief could be considered as a guest here, and the host is a policeman who put the thief inside the jail, and jail is the cage. Now, so this you can see here a neon clathrate. So we shall learn little more details in the next thing, that is what is called as methane clathrates. According to definition we have discussed sometime before, it's a methane inclusion complex. Methane clathrate is nothing but a gas hydrate, means methane is in the hydrate. Now how water molecule can made a cage? It is only possible when water is a solid, because in room temperature water is in liquid form, but only low temperature water forms solid, that is ice. So now from this condition you may consider one thing, that for gas production, for methane clathrate production as well as stability, you need first of all low temperature. Second thing, you need high pressure. Low temperature, why? Because you need to stabilize the ice, point number one. And why high pressure? Because methane is a gas, and actually this clathrate remains in the seabed. Okay, so now how a gas molecule will remain in the seabed? Because gas is a generate tendency, that is buoyancy, which helps them to come out on the surface. Okay, so this is because how this stabilize? First of all, high pressure, which helps the methane to remain in the cage, and second thing, low temperature, which allows the ice cage to be stabilized. Okay, so and how this is means what is the main interaction between the methane and water molecule? This is purely weak van der Waals force of attraction, because we know methane is actually a very less polar molecule, this carbon hydrogen bond, and actually methane is not soluble in water, but under the special circumstances where the compound produces, it has no option except remaining within the cage. Now you can see this is clearly, this is a cage produced by ice, and inside this cage there is this methane molecule. Okay, so actually you may consider this methane is trapped helplessly. Okay, so now, so question, how this is formed? Since this is not that much, means since methane is a hydrophobic molecule, means it has a phobia for water, then how and why it is inside the ice? Because of its preparation. Okay, so just sometime before I told that milder, means that is a near the freezing point of water needed, and high water pressure. So actually since it is produced in the sea, so for that purpose 300-meter depth at least needed. Why? Because in 300-meter depth this methane clathrate molecule get enough amount of water pressure, which allows them to remain inside the cage in a stabilized manner. Okay, so that's how they, and question this such kind of condition where obtained. Example is like Gulf of Mexico, it is in near to USA, and second, or Lake Baikal, that is in Russia. You can see this, you can observe such kind of clathrates are there, and actually in Lake Baikal, when it completely freezes, you can see somewhere some people made a hole and put a fire, and it's burning vigorously. So that's a very funny thing. Now, so this we understand how clathrates are from under this condition. So question, who produces these molecules? Actually microorganism produces this methane under anaerobic condition. Now question, why anaerobic condition? See, actually if you look at the seabed, this is a seabed, and this is, for example, the sea surface, and this depth is 300 meter. Now this sunlight which fall in the seabed can't penetrate long means it can't go at the bottom, this 300, it can't go. So how long sunlight reaches, for example, this much level, up to that much environment phytoplankton exists and they produce oxygen from carbon dioxide, fine. But this zone also, there are some animals who actually need oxygen. So whatever oxygen is produced in the above is consumed by the animals in above, in sea animals or sea creature. Not only that, some below level animals also need. So what happened when you come down, the extent of oxygen or concentration of oxygen inside the sea decreases. So means under this less oxygen condition, and under this environment some special microorganism survives which evolve themselves such a way that they produces this methane under this less oxygen or anaerobic condition. And whenever this methane is produced under this low temperature, near about the freezing point of water, this much amount of pressure, means they are trapped inside this ice crystal and remains for a longer time. Okay, so this is actually a result of anaerobic process, and in this way these methane clathrates are formed. Okay, and this material you can consider as a source of carbon, which organic material. This could be utilized as a source of carbon, as mainly if you say it's a fuel. Now, since I told fuel, how this beneficial? Actually, if you look at their estimated reservoir is far greater than fossil fuel. I know, student, you will be surprised, sir, far greater than the total proven reserve of the fossil fuel. Yes, they are far greater. Means just imagine how much we have. If we can extract them properly and utilize them, then we don't need anything really, better to say. But what is the biggest problem in this context? The biggest problem is that major difficulty to extract them by economically profitable way, and this thing could easily be solved by technological improvement, because we know when there is some problem, when there is a profit, but problem is because of technology, then technology evolved itself in such a way that the obstacle could be overcome. Now, a simple thing will say that, sir, already we are suffering from this global warming and climate change. Huge amount of CO2 we are releasing every day. So why should we focus on these methane clathrates? Let's remain on the petroleum based fossil fuel. That's answer is methane has the highest energy output among all other hydrocarbon and coal, and overall second with respect to everything. That is, first is hydrogen. I have already discussed about hydrogen, so you may visit there. Now, highest energy output among all hydrocarbon. So whatever gasoline you are using, that is a C8, or you are using diesel, that is a C16, compared to all, methane has highest energy output and it burns in the cleanest way. So first of all, from energy point of view, it's important. Second, global warming increases the sea temperature, which will release, we shall discuss more. So to save the planet, we need to means extract and burn this before it directly releases to the atmosphere. So we can consider that this is the least pollutant among all hydrocarbon based fossil fuel. Okay, now so let's discuss details about the global warming and the role of methane clathrates, how it can contribute in global warming. Actually, if you look at this increasing global temperature, mainly sea temperature, will increase the probability of methane escape from the cage and it will mixed in the atmosphere. Question why? See, just some time before, if I have explained the condition for methane clathrate formation, that is near about the freezing point of water. So if you increase if the water's temperature increases due to global warming means the whole globe will be warm. So the water on the surface of the globe will be warm. Consequently, the depth water means above 300 meter where the clathrate from, there will be slightly warm, and this slight warm is enough to allow the methane clathrate to escape from its cage. So and it will mix in the atmosphere, and such kind of thing not only from sea, even in permafrost region, means permanent frost, means permanently covered with ice region, where ice is stopping the methane to release in the atmosphere. So if global warming happens and this ice became thinner, or it can have some break, crack, then methane can come out, and it is actually observed in 2008 Siberian places, Siberian Arctic region, million tons of methane being released. And actually, what is the problem if methane is released? Actually, if you look at, methane is near about 80 times more efficient global warming agent. There are some year based calculations. Student, just consider this: methane is more powerful global warming reagent, means agent, than CO2. So question is, if it is more efficient for global warming, then if it is releases into the atmosphere and stay there, it will damage the environment and it will make the situation worse. Consequently, what is needed? Just convert this methane into a chemical way into carbon dioxide. And if it could be done in exchange of energy, means during this burning, whatever energy will produced, if we can extract them, that is the best for economy as well as environment. So that is the reason why we should focus on methane clathrate extraction, and we try to develop technology such as fast as possible such that methane release inside the atmosphere is less. Now you can see one data, that is the earth atmospheric methane concentration have increased 150% since 1750. And it accounts 20% of the total radiative forcing from all long-lived and globally mixed greenhouse gas. So now you can understand the contribution. Now question, whatever this 50% increase you are observing, are all these due to methane clathrates? Actually student, methane could be mixed in the atmosphere in one is geological way, this one, another geological or geological and plus biological you may consider. There is another source, that is livestock. Okay, so these livestock means these cows, buffalo, whatever they eat, they produce along with that methane. Not only they, even rice cultivation, those things. So please don't be confused that methane clathrate is doing so much damage. Not only we are also responsible for rice plantation and excessive meat consumption. Okay, so that's a different issue, we'll discuss some other video. So now question, since we are confused whether we'll be able to arrest this global temperature rise, so it is better to arrest the methane which is going to release in the atmosphere much possible before and use it for mankind. Means before it mixed in the atmosphere, if we can trap and utilize it, it will be beneficial for the mankind. So that is the scientific background or global warming point of view, its means contribution. Now so see, we have now you consider that through technological innovation we have captured the methane. So how will we utilize it? So first of all, it's used as a fuel. Fuel means it has maximum energy output, as I told, with respect to single CO2 molecule production, and it burns cleaner way than traditional hydrocarbon like petrol and diesel. So less soot production and less pollution. So ideal choice this is. Okay, so it is produces this CO2, and this CO2 is also responsible for global warming, and remember this is also a polluting gas. Second thing, hydrogen production. This is very interesting student. Steam methane remorphing or SMR. I have already discussed about hydrogen production in a previous video. You can see better. So actually right now commercially the hydrogen is produced from natural gas, and where the methane is the most major contributor. So that's why you can say that right now industrial hydrogen is coming from methane, and you can see here more than 50 million metric tons are produced annually worldwide at 2013. So now at 2021 you can imagine how much it's going. And in this case what happens, see, this methane molecule is reacted with water and produces hydrogen. Now if you look very closely, 2 molecules of hydrogen coming from methane and 2 molecules from water. And why this is happens? Because this CO2 is a very stable molecule. I have already discussed about this CO2 thing. Please visit for better learning. So this is the overall hydrogen production, and this hydrogen is utilized for preparation of many value added chemical like ammonia, urea, means hydrogenation of vegetable oils, etc. Now the most important thing is methane to methanol, you may consider it is the dream project of many scientists, methane to methanol. So it is one of the best strategy to use methane, whose boiling point you say very low, means minus 161, and to methanol BP is near about 65, means 64.7 degree for the production, and it could be utilized in multiple ways. So multiple ways means, see, it can easily replace gasoline based fuel, because it's a liquid, easy to handle, it's an alcohol, not that much not that much difficult to handle. I know it's a poisonous, but based on government rules we can do, kerosene is poisonous, but still we are using, and it is very clean, burned very cleanly. Formula 1 racing cars also uses this methanol as a fuel. So means there is a culture already, but not publicly accepted. Now what is the reaction? See, means in methane there are 4 CH bond. So among this CH bond, if you insert one oxygen and other 3 bonds are same, then this is actually methanol. But you see that, sir, this is a very easy thing, it could be done very easily, but in reality it is not that much easy, student. Whenever you react this oxygen with methane, the burning, actually you may consider it's an incomplete burning. Okay, it is very difficult to control the reaction, and ultimately it produces CO, CO2, etc. So that's the problem. So we need proper reaction condition or catalyst such that we can convert methane into methanol in an economically profitable way, and I am very much optimistic that scientists will definitely do that in near future. Okay, so this is the overall thing. Now in conclusion we can say how methane can benefit society. Simple question from everyone's point of view. First of all, it's a green fuel, methane, highest energy output itself. It is a source of hydrogen utilized in petroleum industry, ammonia production, hydrogen fuel cell, etc. This is another interesting, student. If you can prepare hydrogen from methane, hydrogen from methane, it could be used as in fuel cell. Means in fuel cell what happened, this hydrogen react with oxygen and produces water. Okay, and we know that water is a benign molecule. Okay, but in this case it will produce energy, and that energy is utilized for this cars in the fuel cell. And most important thing, if we are able to trap this clathrate released methane, we will be able to reduce the global warming to some extent, which is essential for the climate security of our beloved planet Earth. Okay, so this is the end of the discussion. Thanks for watching, and please remember, as the most intelligent species in the earth, we need to take care of our universal mother nature. Bye bye.